What is a cascading power grid failure? Have you ever wondered how a single failure in an electrical system can lead to widespread blackouts? This phenomenon is known as a cascading power grid failure. It starts with one component, like a transmission line or transformer, failing. This initial failure causes a shift in electrical load to other parts of the grid. If those components cannot handle the extra load, they too may fail, creating a chain reaction. Imagine a scenario where a transmission line experiences a fault due to aging infrastructure. This fault can overload neighboring lines. As these lines become stressed, they may trip offline to protect themselves. This action redistributes the load, leading to further failures. The process can escalate quickly, resulting in large sections of the grid collapsing and causing a blackout. Several factors contribute to these cascading failures. One key factor is power angle stability failure. This happens when generators lose synchrony, causing parts of the system to fall out of step. Another factor is overload chain reactions, where excessive current flow causes equipment to trip or fail. Voltage collapse can also occur when the system cannot maintain voltage levels, leading to rapid drops. Lastly, frequency collapse happens when there is an imbalance between power supply and demand, causing frequency deviations that can damage equipment. These failures are challenging to predict. They involve complex interactions within the grid. Protective systems designed to isolate faults can sometimes make things worse. When they disconnect components, the load shifts elsewhere, potentially causing more failures. From the perspective of industrial and technological accidents, cascading power grid failures can be particularly dangerous. They can lead to prolonged blackouts affecting millions of people. Critical infrastructure, like hospitals and transportation networks, can be disrupted. This poses significant risks to public safety and economic stability. Natural disasters often trigger these failures by physically damaging grid components. However, the cascading effect magnifies the initial impact far beyond the original fault. To improve grid resilience, it is essential to focus on better maintenance and advanced monitoring. Rapid response strategies can help isolate faults before they spread. Practical measures include upgrading aging infrastructure and implementing smarter grid technologies. These technologies can dynamically reroute power, helping to prevent minor issues from escalating into large-scale blackouts. Training operators to manage emergencies effectively is also vital. By understanding cascading failures, we can work towards a more reliable and stable power grid for everyone.